Okay, so on this worksheet, what you wanted to do was to find, and these are all square roots except for one, two of them, which is a cube root, or three, which is a cube root. So either you're finding the cube root or the square root of each expression. Now notice that the radicands are variable expressions, okay? Now here's the way to deal with this. All right, so let's look at number one. And again, in these lessons, we're going to assume that all variables represent positive numbers, so you don't have to worry about absolute value. So number one, here's what you have to do. We have the square root of m to the 22nd power. Okay, now you had to use this fact. You had to use the rational exponent idea. And here's the idea. Okay, you have to remember this rule. So if I have the b root, okay, the b root of a to, let's say, the c power, all right, the b root of a to the c power. So a radical can be written as a rational exponent. So it becomes a raised to, and then a rational exponent, meaning a fraction, c divided by the index b. So I can always write a radical expression as a rational exponent expression. So using this idea here, this becomes m to the 22nd divided by, and the index is 2, and then 22 divided by 2 is 11. So I get m to the 11th. And so there's your answer. Okay? So the square root of m to the 22nd power is m to the 11th. And for the most part, you can use this idea that I'm about to remind you of. You can see how this is an even exponent and this is even. This is 2, square root 2. Just say 2 into 22 is 11. But keep in mind, though, that you don't have a radical any further because your exponent, 22 divided by 2, was a whole number. Okay? So since that was a whole number, I no longer have a radical. In another lesson, you're going to see where this is not going to be a whole number, and you're going to see what's going to happen. But in this worksheet right here, whenever you write it as a rational exponent, this is going to be a whole number. Okay? All right, number 2. So number 1 was m to the 11th power. Number 2, you have the square root of x to the 8th. Okay, no big deal. I can handle that. I can use this property right here. So that becomes x raised. All right, now we need to write this as an exponent. You need to write the radical as an exponent. So the 8 here becomes your numerator, and your denominator is your index. The denominator is your index, so that's 2. So remember, the denominator is the index. Okay? The denominator is the index. And so therefore I can simplify this. 8 divided by 2 is 4, and there's my answer. So x to the 4th power. So the square root of x to the 8th is x to the 4th. Okay, number 3. You have the square root of 49, x to the 12th power. All right, now the way you want to do this, you see how in number 1 and 2, the coefficient here is 1. 1 times m to the 22nd, 1 times x to the 8th. This is 49, x to the 12th. The way you want to do this is you want to write this as a product of radicals. In other words, this right here is the same thing as saying the square root of 49 times the square root of x to the 12th. Okay? And so basically using this property right here that says the square root of a times the square root of b is the square root of a times b. That's what you're using. Okay? So the square root of a times the square root of b is the square root of a times b. Or the square root of a times b is the square root of a times the square root of b. And that's what we used here. And now I know that the square root of 49 is 7. And this right here, do y'all agree that I can write as a rational exponent? That would be x to the 12 divided by 2. And so my answer then will be 7x to the 6th power. All right, so that's number 3. So number 2, the answer is x to the 4th. And then number 3, it was 7x to the 6th. Okay? All right. Now, number 4. Okay? So number 4. Here's number 4. Number 4. we have the square root of 100x squared. All right, I'm going to do that just like I did this. All right, write it out. Take the time and do this properly. So there's the square root of 100 times the square root of x squared, right? And so the square root of 100 is 10, because 10 times 10 is 100. And the square root of x squared, I'm just going to think about it. All right, well, that will be x to the 2 divided by the denominator, remember, is the index. And my index is 2, and 2 divided by 2, 2 divided by 2 is 1. So I get x to the first, which is x. So that's 10x. All right, number 5, we have the square root of 25, x to the 4th, y to the 10th. All right, now again, this worksheet is the easy kind, because notice that my final answer no longer included any radicals. Now in another lesson it will. So it does help if you write it like I'm doing right here. In other words, it does help if you write this as the square root of 25 times the square root of x to the 4th times the square root of y to the 10th. It does help. And now at this point, with those two radical expressions right here, I'm going to use this property. So the square root of 25, I know is 5, because 5 times 5 is 25. X to the 4th, I'm going to go ahead and think about it right here. So remember, the square root of x to the 4th is x to the 4th divided by the index, which is 2. So that's x squared, right? So that's x squared. So that becomes 5x squared. And then the square root of y to the 10th, that'll be y to the 10th divided by 2, right? Which is y to the 5th. And so there's your answer for that one. Okay? And then number 6. Number 6, we have the cube root of 64, m cubed, n to the 12th. All right? Same thing. Write it as a product of radicals. So that's the cube root of 64 times the cube root of m cubed times the cube root of n to the 12th. And then you're going to ask yourself, what whole number times itself 3 times? Because that's a cube root is 64. So the answer is 4. Now let's talk about this one right here. Let's think about what this is. So I'm going to go ahead and write it right here. I'm going to write it right here. So the cube root of m cubed is what I'm looking at. So do y'all agree, writing it as a rational exponent, that's m, this exponent right here is your numerator, the index is your denominator, and 3 divided by 3 is 1, so that's just m, right? So that's m right here. So that becomes m. 3n to the 12th, I'm sorry, the cube root of n to the 12th, cube root of n to the 12th, that's going to be n to the 12th divided by 3, because remember your index is your denominator. 12 divided by 3 is 4, so that's n to the 4th. And so there's your answer. Okay? So far we have this. So far in number 4, our answer is 10x. Number 5, the answer is 5x squared y to the 5th. And then 6, the answer is 4m n to the 4th. Okay? All right, let's look at number 7. All right, number 7, we have this. All right, number 7. Okay, so number 7, we have the cube root of negative 125, x to the 6th, y to the 15th, z, that's a z, to the 9th. Okay? All right, so write it as you have 1, 2, 3, 4 factors, so to speak. So write it as a cube root of those 4 things. So in other words, take the time and say, all right, I know that I can write this as the cube root of negative 125 times the cube root of x to the 6th times the cube root of y to the 15th times the cube root of z to the 9th, right? And so I know from a previous lesson that the cube root of negative 125 is negative 5. And then at some point, you'll be able to do this in your head now. But at this point, let's probably you know what this is now. That'll be x to what power? 6 divided by 3 is 2, right? You don't have to do all that work. Y'all agree? 6 divided by 3 is 2, so I get x squared. 15 divided by 3 is what? 5, so I get y to the 5th. 9 divided by 3 is what? 3, so I get z cubed. Did you have to do all that work we did a while ago? No, you didn't have to do any of that. But if you need to, there's nothing wrong with doing it. So if you have to write out, for example, if you have to write out that the cube root of x to the 6 is 6 raised to the 6 divided by 3 power, and then that's x squared, then do that. If you have to say that the cube root of y to the 15th, using that rational exponent property, is y to the 15 divided by 3, which is y to the 5th, then do that. If you have to say the cube root of z to the 9th is z to the 9 divided by 3, which is z to the 3rd power, then do that. But at some point, you'll be able to recognize, hey, 6 is divisible by 3, so I get this whole number. 15 is divisible by 3, I get this whole number. 9 is divisible by 3, I get this whole number. And so number 8, you have the square root of 16x to the 6th divided by y to the 4th. And just like a previous lesson, you're going to write this as the square root of 16x to the 6th, the numerator, divided by the square root of y to the 4th. Okay? Now let's look at the numerator. And again, many of you can do this without even doing all this work right here. So many of you can say the square root of 16 is 4, and the square root of x to the 6, 6 divided by the index, which is 2, is 3. So that's x cubed, right? And then here the index is 2, so y divided by 2 is 4, so you get y squared. So you can do that in your head. There's really no work to do. In fact, for that right here, you can go from here to here without doing any work. So without any work, you can get the answer. Okay, but if you need to do the work, then you do it. For example, look at the numerator right here. If you have to say this, then that's fine. The square root of 16 times the square root of x to the 6, and then the square root of 16 you know is 4, and the square root of x to the 6 is x to the 6 divided by the index, which is 2, because square root. So that becomes 4x cubed, and that's what that numerator was. And then in the denominator, if you have to work it out, then work it out. The square root of y to the 4th is y to the 4 divided by 2, which is y squared, and that's that denominator. But you didn't have to do all that work. At some point, you'll be able to go from here to here very easily without doing any work, because you'll be able to do that in your mind. Okay? Number 9. Number 9, you have the cube root of 216 x cubed y to the 30th power divided by z to the 9th. Okay? So most of that is going to be pretty easy at this point. Without doing any work, you can really go from here to your answer. So if you look at 216, now this is a cube root of 216. So what number, so the cube root of 216, what number times itself 3 times is 216? All right, so you know it's not 5, because 5 times 5 times 5 is 125. Well, what about 6? 6 times 6 times 6. Well, 6 times 6 is 36, and 36 times 6 is, let's see, 6 times 6, 36, 18, 19, 20, 21, 216. So the answer is 6, right? Okay, so 6. So so you could have done this with your calculator. So the numbers won't be that big to where you need your calculator. You will not need your calculator with these. So the cube root of 216 is 6. So you see, you're doing this without showing any work. So, and then what's the cube root of x to the 3rd? Well, 3 divided by 3 is 1, so that's just x to the 1st power, right? And then y to the 30th, the cube root of y to the 30th is 30 divided by 3, which is 10, so y to the 10th power. And then what's the cube root of z to the 9th? 9 divided by 3 is 3, so that's z cubed. Okay? So you see, you went from here to here without any work. But if you have to show the work, so remember, you did this without no work. But if you have to show the work, then show the work. So you would say something like this. All right, let's look at the numerator. So my numerator is this. I have the cube root of 216 x to the third y to the 30th, correct? And so I can write this as the cube root of 216 times the cube root of x to the third times the cube root of y to the 30th. And so the cube root of 216 I know is 6. And then here I can write this as x to the 3 divided by 3. And I can write this as y to the 30th divided by the index, which is 3. And so simplifying this, now remember that's not the answer to the whole problem because I had the denominator. But simplifying this, I get 6x, 3 divided by 3 is 1. And then 30 divided by 3 is 10. And so that's your numerator. Okay? And the denominator, do the same thing. So that's the cube root of z to the 9th, right? So that becomes z to the 9 divided by 3, which is z cubed. So that's your denominator. And then finally, number 10. So far we have this. We have, let me fill out the answers. So number 7, we got the answer to be negative 5, x squared, y to the 5th, z cubed. Number 8, it was 4x cubed divided by y squared. And number 9, it was 6xy to the 10th divided by z to the 3rd power. Okay, and then finally number 10. So number 10, we have this. Number 10, we have the square root of 121 x to the 12th power divided by 16. All right, now again, you can do this without any work, right? So you can go from here to the answer without showing any work. So if you don't do any work, in other words, you're doing this in your mind, you can do this in your mind, and that's easy to do. So the square root of 121, what number times itself is 121? The answer is 11, so that's part of your numerator. And then the square root of x to the 12th, 12 divided by 2 is 6, that's x to the 6th. And then the square root of 16 is 4, right? But if you have to do the work, then do the work. So the numerator, if you look at the numerator, that's the square root of 121 x to the 12th. And so that becomes the square root of 121 times the square root of x to the 12th, right? And we know that the square root of 121 is 11, because 11 times 11 is 121. And then here, that's x to the 12 divided by 2, and 12 divided by 2 is 6. Okay? Now, some of you get caught up pretty quick on some of these things. You go too quick, and what I'm saying is this, about to say is this. Some of you are going to say the square root of 121 is the square root of 11. That's not true, okay? The square root of 121 is 11 because 11 times 11 is 121. That's not true. The square root of 121 is not the square root of 11 because the square root of 11 times the square root of 11 is 11, not 121. Okay? All right, so be careful. All right, so that's the numerator. And the denominator, the square root of 16, obviously is 4, right? Okay? All right, so that will be the answer to number 10. So number 10, we have 11 x to the 6 divided by 4. Okay? All right, so just remember about this. Don't say that's the square root of 11. We know that the square root of 121 is not the square root of 11. The square root of 121 is 11 because 11 times 11 is 121. The square root of 11 times the square root of 11 is not 121. It's 11 actually. Okay? All right, so that is the key to section 15.1, part B.